Okay, so this is my first kind of video talking about this, because I feel that if I had struggled with this, then many other people have struggled with this, and yeah. So I'm gonna just do this little quick video. I don't know if I'm right. Well, I still got the right answer, but I didn't do it this way. I did it a different way, and I technically I it just was a lot. Okay, so I kind of figured out maybe what the problem was and, what was I not doing. And I'm just here to share. So, what is going on here? Okay. So, let me delete this. Okay. So, I said to myself, okay, if I know that the first rotates points is through negative 5 pi over 3. And I'm like, what are you talking about? Negative 5 pi over 3, where is that on a unit circle? But I said to myself, I don't know if you know this, but it's like the unit circle, it rotates two times pi. I'm not really gonna do the proof on it. I just trust the fact, and it worked. But that's what it does. So I did 5 pi over 3 plus 2 pi. So then you just do common denominators. So then this is technically saying 2 pi over 1, and then, times it by 3 and stuff like that. And so then in the end, you would give pi over 3. So I'm like, that's fantastic, because I actually do have a pi over 3. So it makes our life a lot more simpler. So that's why I kind of deleted it when I first did it. But this is what I was talking about. Oh, sorry. Okay. So knowing that, I was like, okay, so let's see, where does these points add up? So I see that we have a 1/2 for the x coordinate and radical 3 over 2 for the y coordinate. So, but what I would say is that I know this is a unit circle. So it's going to be the balance between negative 1 to 1 inclusive, right? And we're talking about sine and cosine here. And as you can see where I labeled it, this is the x and this is the y, right? So I said to myself, okay, so I know that cosine is the x and then sine is the y, right? So I'm saying, okay, cool. So cosine is, for here, it's the 1/2 and then radical 3 over 2, right? So but this is like in points, but we have to do it in vectors, right? So we'll just say v is equal to x, y, which is how this goes. And then you would just do v equals the 1/2 and then radical 3 over 2. That's how you would write it for it, right? So let's go back to the problem, right? And okay, so I want you to point out, well, I'm going to point out something that's really important that kind of stood out to me, right? It said that it first rotates points through pi negative 5 pi over 3, which we found that, I guess, like, where the radians are on, like, the simplified version of the negative 5 pi over 3. This is a pi over 3, which was, the vector and stuff like that. And it says, and then it reflects points through the horizontal x1 axis. So I'm like, if it reflects, right? So every time I think of a unit circle, I think of pre-calculus, I think of calc 1, I think of calc 2. So if it's saying that it reflects, you can also do this if you by it being how you know that cos is even and then the sine is odd. You can also do it like that too, and then do it. It's more practical. I've seen it done with, like, researching it. I've seen it done being I've seen the reasoning being like this, but this is just something that I noticed, right? So I noticed that when it said reflex, right? Oh, sorry, reflex. So I'm like, if it's reflecting, I'm like, okay, let me keep this in mind. So knowing this, we know that the x is the cos and the sine is the y. So I'm like, I know that I'm gonna have to put this in a matrix that has 2 rows, but I'm going to need to know what my other column is, right? So let's put the cos right here and then the sine right here. So I'm saying to myself, if it reflects, that means that it can inverse each other. That means it inverses each other. So like if you see like a mirror, right? Your reflection in the mirror, or maybe your reflection on camera or something like that, you're inverted. You're not, you know what I'm saying? Like your left hand is going to be the right and all this different types of stuff. So I'm thinking to myself, okay, how does this relate to math? If it reflects, that means there has to be some sort of inverse or anti-inverses, right? It has to undo each other if it reflects. So at some point, so I said to myself, okay, I need to think of antiderivatives and derivatives, because I noticed, I'm gonna put this right here. Sine, cosine, negative sine, negative cosine. So I have cosine and sine here. So I'm saying to myself, okay, what is the derivative of cosine? Negative sine. So I'm putting negative sine right here. And then I'm saying to myself, what is the derivative of sine? Cosine. Oopsies. Sorry. So I'm like, okay, that makes more sense. If it reflects, I can always go back up here. I can always take the antiderivative of this, and it will go back to the spots that it was before. So I'm like, okay, I have a little bit more bases now. But however, I'm still going to have to fill in the second column, this column, right? So I'm like, okay. So we're going to fill in the cosine, which is 1/2 3/2. And then with the negative sign, as you can see, I don't know if you can kind of maybe see a pattern, I guess. But oh, that yellow right here. So you're just going to you're just going to negate that. That's what you're going to do. You're going, what color was I? I don't know. Let's do this one. I don't know, it's a little lighter, but whatever. So you're going to negate that. Oh no, it's the same color. And then you're just going to bring the 1/2 down here. Okay? So noticing this, I'm like, okay, now I have my second column. Now I'm able to find the standard matrix of T through the horizontal x1 axis and all that stuff, right? So what I did was I kind of like said to myself, okay, if I know that this, I know that this is my coordinate for the 1/2 and the negative 3/2. So it talks about the horizontal x1 axis. So I had to kind of search in onto this, because I had to see what kind of, what it was about. So the x1 axis, you would use the coordinate system 1 and 0. If it's regular, it's non-skewed coordinate system. Like there's not a drastic change or anything like that. It's just a regular coordinate system. And yeah, you're just dealing with like rotations or other transformations in a regular coordinate system. It's always tied, x1, it's always tied to 1, 0. But in this case, we have to create it as a vector, right? So creating this as a vector, I knew if I am going to reflect this, just how we reflected this, I said to myself, okay, so then I would just have to flip this, just flip the signs. So the 1, oopsies, the 1 turned into 0 and the 0 turned into the -1. So I would say kind of just did this and then negated it. And then it kind of just did this and then negated it. But obviously you can't have like a -0. So that's just how, that's just kind of how it's framed. So you literally just like flip the signs. So after that, what you would do is we have everything that we need. We have the 2 columns, and then we also have the x1 and the x2 for the coordinate system, the horizontal coordinate for the x1 axis. So you would just have to multiply this, and this. So, please. Yep. So, by now you probably should be familiar on how to multiply this. So, the first column, I'm gonna just write it down since I'm already kind of on a crunch, is the 1/2. It's 1/2, and then it's the negative 3/2, and then second column is -3/2, -1/2. So you will put this in the same order that you kind of solved it in, right? So I'm going to take my 1/2. So this remains unchanged. This row is unchanged. Well, that doesn't really spell unchanged. Row is unchanged, and then it turns into 1/2, and then I think -2. So then after that, you will put in the second column, which is 3/2, -1/2, but this time it's going to be a -1/2, not a positive. And so this would have been your final answer, and this would have been my final answer, but I kind of got stuck up. So yeah, I hope this video was helpful. And yeah, if you have any questions, comment them down below.